Hello there. So today we're going to be starting on IP addressing and subnetting. We're going to be going a bit more deeper into this specific topic, and it's going to be a quick revision as well. So the first type of question that they can ask you from IP addressing is they're going to give you an address, say like this, and it's going to be something like a classless address. So say they give /24. So what does this /24 mean? Well, when it comes to binary, an IP address has 32 bits, right? Each divided into 4 octets, each having 8 bits. So this number says from left to right how many numbers are reserved for the network address. So in this case, 24, meaning 8, 16, 24 is reserved for the network, and this 8 is reserved for the host, meaning this is the only address that we can change, right? So there are 2 to the power 8 number of bits here. That's going to be 256. That means there are 256 different combinations that we can have for the host, 256 different addresses that we can have. So let's say that they give you something like this, and then they say something like find the network address of this. Then they say find the, let me write it down. They can ask for the network address. They can ask for the broadcast address. They can ask for the number of usable addresses. And then they can ask number of total addresses that are available. So to find number of total addresses, I believe I have already demonstrated here. We see how many bits are free, that are host bits, and then we go 2 to the power 8, meaning giving 256. So you might say, okay, we can use 256 number of those addresses, all of them are usable, right? But no, we have to always reserve the very first address for the network address. It will always be reserved. It will say, hey, this is the network address. The last address will always be reserved as a broadcast address. So everything in between, only these are usable as usable addresses. So it's always going to be, let's say if 32 minus 24 is equal to an n. This is a, oh wait, my bad. Let's actually define this a bit more clearly. Let's say n is number of network bits, right? And m is number of host bits. So we can get, so the connection between them is 32 minus n is always going to be equal to m. So to find number of total networks, we do 2 to the power m, right? That is total. To find usable, we do 2 to the power m minus 2. That's going to give us usable, right? So what is the network address of this? Well, the network address of this is, as you can see, this is the very first address that we can use. So this is the network address for this specific IP. What is the broadcast address? Well, we have to find the last one. Now you might say, okay, the last one is obviously 192.168.4.256, right? Because 256 is the last number. Well, you're wrong. It's actually 255. Why? Because the first value is actually 0. So that if 256 is the last one, so it's going to be 255 because we count 0 also as a valid value, right? So this is your network address, this is going to be your broadcast address, and anything in between are all the usable addresses. Now that is for 24. What if they give you something like this? 192.168.4.0/27. Well, if they give you something like this, the first thing which you must do is subtract 27 from 32. That's gonna give you a 5, right? So then you go 2 to the power 5, which is gonna be 2 in 32. That's gonna give you 32, right? So essentially what's gonna happen is it's gonna be broken into these blocks. So I recommend you write first start with a 0, then go 32, 64, then if you add another 32 here, you're gonna get a 96. If you add another 32 here, you're gonna get 128, so on and so forth. Then you subtract 1 from each of these numbers. 63, 64 is gonna give 95, 127, so on and so forth. These are what's called as blocks, network blocks, right? So let's say they are asking the network address, all the other top 4 from this value, right? So 51, where is 51 coming in this set? So I believe 51 comes right around here, right? Because it's greater than 32, less than 63. So the network address of this IP address is gonna be 32, right? 27. This is the network address. And then it's gonna give you 192.168.4.63. This is gonna be the broadcast address for this IP, right? This is for this IP, this is the network address, and this is the broadcast address. Okay, so how many addresses are usable here? Sorry, how many total addresses are here? 32. How many of them are usable addresses in this block? 30. Why? One is reserved for the network, one is reserved for the broadcast. Always subtract 2, right? So let's do one more sum. Let's say it is 192.168.0.0 slash, let's say 20. Okay, let's say 20. What does this mean? Well, if it is 20, let's subtract 32 minus 20. It's going to give us 12. But in network, we know that the maximum we can write is 255, 255, 255, 255. But 2 to the power 12 is way bigger than 255, right? It's not equal. Remove that sign. This is way bigger than 255 because 2 to the power 8 is equal to 256, right? So what should we do in that kind of scenario? Well, basically, I guess any mathematicians here or anyone with a little bit of common sense would figure it out. We break this into blocks. So 12, we do 8 and 4. So here we have 2, 5, 6. Here we have 8 and we have 16, right? We have, basically we have 16 here. So how this will break is, it's gonna go from, this is gonna break into chunks of 16 and this is gonna break into, so essentially we don't have to consider this one, we just have to consider blocks of this, right? So we're gonna put 0 to 15, 16 to 31, sorry, not 31, is it? Yeah, I believe it's 31, 52, and then if you add a 16 here, you're gonna get 48, you're gonna get a 47. You add a 16 here, you're gonna get a 4, one more balance, 60. So this is 63, so on and so forth. So for this specific one, the network address is gonna be 192.168.0.0. This is the network address. Broadcast address of this is gonna be the last one. So 192.168.15.0. This is gonna be the broadcast address. No, it's not going to be 0. Pardon me, my mistake. 255. That's going to be the broadcast address. So any address in between are usable addresses. So how many addresses are usable here? Well, then that's always going to be 2 to the power m minus 2. So it's actually 2 to the power 12 minus 2, right? So that's the number of usable addresses here. How is that possible? We have 0 to 15, that gives us 16 values. 0 to 255, that gives us 256. So that's actually 16 times 256, which is 2 to the power 4 plus 2 to the power 8 is going to be, sorry, multiply 2 to the power 4 plus 8, 2 to the power 12, right? So this is essentially all about network addressing, right? So that's what you get. So if let's say, let's do one more example for this one. How about we do something like this? So let's say they give you 192.168 40.8, and they give you slash, let's say they give you slash 20 here. Now slash 20, always do 32 minus 20 is going to give you 12. 12 is 4 and 8, right? So 4 means 2 to the power 4, 16, 2 to the power 8, 256. So 16 is going to be 0 to 15. It's going to be 0 to 255, right? Right. So now what we should do is we should find this one's network address and broadcast address. Then we should find the usable addresses and all. Well, then let's first of all do the chunks of this. So it's going to be 0 to 15, 16 to 31, 32 to 47. 40 falls under this block, right? So I believe it's going to be 192.168.32.0, right? Right. So this is the network address. Don't forget the slash 20. This is going to be the network address. Then we have 192.168. The last one is going to be 47.255/20 as the broadcast address, right? So how many addresses are usable address? Well, 2 to the power 12 minus 2, which is a value which you can calculate using the calculators, which even a basic calculator has power function, so you can find it out, right? Also remember, 2 to the power 12 minus 2 is not equal to 2 to the power 11. Okay, this is 2 to the power n minus 2 is not equal to 2 to the power n minus 1. This is wrong. Okay, so right now we have learned about how to do, IP addressing. Let's talk about subnetting. So let's say that there is a network address of 192.168.4.0/24, right? That means only the last 8 bits, sorry, that means the last 8 bits are only workable, basically, because all the others, these 3 are locked. Let's say a company needs 6 different subnets. Okay, they need 6 different subnets. So what does that mean? First of all, let's look at what that means. So since we know that all of these ones are not changeable, bits are not changeable, that means only the last 8 bits are changeable, right? That means as 1, 2, 3, 4, 5, 6, 7, 8. Since there's only 6, meaning these ones, the ones that are marked in blue, these guys are the only ones who will stay stuck, right? So that means we will make this into a subnet address, right? So they can be 0, 0, 0, 1, 1, 0, 1, 1, right? So that's how we can do it. But that doesn't give us 6 different values. Did you understand? That doesn't give us 6 different values because we are like, we need more addresses. So we take in this one as well. Now we have 0, 0. I want you to imagine that this goes something like this, right? 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now we have 8 different, blocks, 8 different blocks. But we don't care. We think, oh, there's 2 extra. Fine, they can be probably used for 2 different later subnets. For now, we have 6. That means we are reserving some part of the host for a subnet work address, right? We are reserving some parts of the host as a subnet address. So essentially what we're doing is we are saying how many blocks can we create. So let's say, so instead of thinking in this manner, there's an easier manner to think of this problem. Let's say that we have blocks of 256, 0 to a singular block of 256. That only gives us one block. That only gives us one entire address set. We can't have it. Let's say we have 0 to 127, 128 to 256. That gives us 2 blocks. Still not enough. 0 to what's the 63, right? If we do that, we're going to get 4 blocks. Still not enough, right? But let's say 0 to 31, 32 to 63. If we do that, we're going to get 8 blocks. That means 8 is greater than 6, meaning that's enough for us to make, addresses. So essentially, that is the thought process behind this. So they want 6 different subnets using 192.168.4.0/24. They want 6 different subnets. So we can break this into subnets with, so they're saying we want to arrange last 3 digits, right? So that will mean 1, 2, 3, 4, 5. That means these 5 are the only guys who are able to change. These guys will change accordingly. So what we can do is we will change the prefix to /27. We will allocate these also for the address. So you might say, okay, subnet mask, why can't we add 24 plus 3 or something like that? Well, it is actually there so that, we can make it simplify. It. Right? So essentially now we have a proper system. So we have 192.168.4.0 to 192.168.4.31. This is a singular subnet. 192.168.4.32 to 192.168.4.63. This is another subnet. That is what the process of subnetting is, right? So let's look at a hard example. 192.168 again 40.8, right? No, 40.0/20. Okay, so /20, like I said, 32 minus 20 is going to give us 12. 12 is 8 and 4 and 8. 8 is going to give us 0 to 255. 0 to 15 is 4, right? So now we need to arrange this into blocks of we need to arrange this into apparently blocks of let's say they want how many subnets. So essentially you can make so many subnets with this, but they only want how much? Let's say 16 subnets. They want 16 subnets out of this. So if we take 0 to 255, if we divide it by 16, so let's say 256 divided by 16, you're gonna get something like 4, no, 8, 1, 8, 4, 4, 2, 1, 16. So you're gonna get 16 here, right? So essentially, you don't even have to work that hard. Since this entire thing is reserved /20, we can go 192.168.0.0, and then the last one can be 0.15, right? Then 0.16, and so on and so forth. This is absolutely a waste of space to reserve for 16 IP addresses, right? So I believe you have understood the concept of how to do this, and I hope you understood. Sorry if I didn't explain it well enough, and hope you have a great day.